Okay, guys, I think it's time to make a start. So, my name is Václav Brzezina. I'm a researcher at the CAS Research Centre. So, we are a large corpus linguistics research centre here in the UK, interested in the application of corpora in all sorts of areas of social research, social science research. And I'm really delighted that so many of you came along and joined the humanities and social science summer schools. Well, this lecture in the morning is an introduction to corpus statistics, and some of you might be thinking, well, do I really need statistics? And does it really make sense in the context of my research? What I would like to convince you about in this lecture is that statistics is not about number crunching, but statistics can be about understanding the general principles of quantitative analysis, which, as I would like to argue, are important in any area of research, certainly in corpus linguistic research. So I would like to invite you on a journey together through some of the numbers, but not too many numbers, but through some of the main principles of statistical thinking. And I'll show you what I mean by that in a moment. So, in this lecture, I would like to address 5 main questions, and let's see whether they will make sense to you from your perspective, from the perspective of your individual context or your individual research interests. Well, why should statistics be useful? And I think that's an important question to ask. Think about the basic principles and the motivation. Why should we care? Then I would like to start talking about the research design and corpora. And I think that's a very important starting point, because lots of the statistical courses skip this point. However, corpora and how corpora are put together are very important for any further analysis. So this is a natural starting point to think about the data, the corpora. Then we'll move on to descriptive statistics, and we will be asking the question, what can we see in the data and how to describe that in very simple terms. Then we'll look at something more sophisticated, and that is p-values and null hypothesis testing within the paradigm of inferential statistics, when we take the data and want to make some inferences about the language as such, about the population as such. So how to do this in some principled way, we'll just talk about the basic important principles there. And at the very end, I would like to mention some 10 statistical principles as a sort of a take-home message that I think can be useful for you, potentially useful for you, when you think about your own research and how to work with data and how to quantify the observations that you might have in your data. So how does this sound as a plan? Okay, well, we'll see. I'm not sure what your first reaction is when you see a slide like this one. Some people cringe. Some people start solving the equation. I'm not sure, which category you belong to. But as I said, I don't think statistics is about number crunching, because we as humans are not particularly good at this activity. Computers are much better at that. So I would delegate this task to computers as long as we know the basic principles, the philosophy of statistical thinking that I would like to guide you through in this lecture. However, before we do that, what I would like you to do is turn to the person sitting next to you. If you haven't met or haven't said hi yet, please do say so, and take a moment, a minute or two, to discuss these 2 questions. What is your personal experience with statistics, if any? And I don't expect any experience, so that's absolutely fine if you have no experience whatsoever. And do you think that statistics should be given more prominent place at schools, universities, in the educational systems, and why? So have a go at it now. And we return back to our large group. I know that some of you are still discussing, but just a very quick show of hands. How many people have some experience, even very little experience with statistics? Just show of hands. Okay, that's great. That's brilliant. Yeah, so we have something to build upon. Any particular areas of statistics? Any particular statistical terms that come to mind when I say statistics? Which springs to mind? Frequency? You have to shout at me. Regression, okay. It's a very complex statistical model. Okay, brilliant. Anything else? Standard deviation? Chi-squared test? ANOVA analysis? Factorial analysis? Oh, wow. We have some stats pros here in this group, which is absolutely wonderful. What about statistics in our educational system? What do you think about that? How many people think that there should be a more prominent place or more prominent position of statistics in universities and education as such? Just show of hands again. Okay, sort of half-half. We are, in statistical terms, we are sort of a self-selected sample, biased really, because you are here for a reason, to learn something. So that probably doesn't reflect the general population so well. But I think, you know, my take on that is it really depends on what you want to teach in statistics and how you want to approach it. Because when I talk to our undergrad students here at Lancaster and when I introduce them some sort of statistical concepts, they, you know, first of all are really apprehensive, thinking, oh, you know, should I be doing this? And, you know, when I ask them, okay, you know, what's your experience with statistics, mathematics? They say, well, you know, really, no, I'm not really that keen. I'm doing English language because I hate mathematics. So that's the sort of type of reason that people have. And I think, you know, that's a perfectly valid reason. And, you know, sometimes statistics, mathematics are taught in a way that is not that encouraging for a lot of people. So let's see, you know, what we can do in these 2 hours together and whether statistics will make sense to you after this. So what I would like to offer in this lecture is my take on statistics. Some people might agree, some people might disagree, and that's absolutely fine. But this is my perspectives on why is statistics useful, in particular for corpus research. So I won't be talking about statistics in general, but statistics as applied to language data. Okay, well, a definition of statistics might be a good starting point. A traditional definition by Diggle and Chatwin says that statistics is a science of collecting and interpreting data. And I think, you know, there's a very good point here. Statistics is not about analysis only, but statistics guides us through the whole process of data collection and data analysis. So I think that's very important to bear in mind. My take on statistics is really that it is a toolbox, a discipline which helps us make sense of quantitative data. Whenever we count something, and in corpus linguistics, we usually count frequencies of words or phrases or grammatical structures in a corpus. Whenever we count something in language or elsewhere, we need to have some tools so that we can make sense of what is going on in terms of the quantitative information, in terms of the numbers. And I also like Tufte's, Edward Tufte's definition of statistics, which is a very broad one. Tufte says, you can think of statistics as learning from experience. And I really like that, because I think we can relate statistics to everyday life. And, well, experience, obviously, is the data, right? What we collect empirically, what we go through. Well, in science, we formalize this, but we do this on an everyday basis. We have something like statistical learning probably in our lives as well. We sort of reflect on what we've experienced and try to derive some conclusions based on that and probably avoid some mistakes if we can. So I think statistics really relates to everyday life as well as science. Okay, what can we do in very practical terms with statistics? We can generalize, and these are very basic examples I want to show you. Imagine, and this is a real example, I'm interested in the use of adjectives in fiction writers. right? Sort of a stylistic mini-study, if you like, in the British national corpus. And these are the real numbers. I've just selected a tiny sample of 11 fiction writers, randomly selected from the British national corpus. I counted the number of adjectives. And you can think about the motivation of the study. Well, you know, the type of style that has many adjectives is this sort of colourful description and very sort of nice, elaborate style of writing. So I'm, you know, trying to count this. Here's a list of these authors and the sort of frequencies of adjectives in their writing normalized, so that, you know, we are comparing like with like. And it is ordered from the smallest number to the largest number. And the question is, what is the overall picture? You know, how would we actually generalize over this line of 11 numbers? But, you know, in British National Corpus, there are 4,000 different texts. So, you know, there will be quite a long line of numbers if we imagine the whole corpus as a line of numbers, right? Well, one of the ways, and you are probably familiar with that, is to compute something that is called the mean, the average value, right? And we probably do that, and you know, we probably even don't think about that. We just, you know, get the average. We add all the numbers and divide it by the number of cases and get the number that sits somewhere in the middle. In this particular case, it is 591.45, right? And this number can be taken as the central tendency, as the measure of the central tendency, the number that summarizes the whole data set. So we don't have to name all the individual numbers, we can just quote this one number, right? And this is a very basic statistical operation of generalizing. However, we can take a different number. We can take a number that we call a median. And in this particular case, it is the number sitting right in the middle of the ordered list of values, right? And again, we can say, and median is a different number. It's a different number from the mean. It's the middle number, right? A real number in the distribution. And we can say, well, you know, let's take the middle number to represent the whole group, right? It's a sort of a label or representative of the whole group because it's sitting in the middle, so it is representing the one on the one edge and the other on the other side of the extreme of the distribution, and you know, and the other ones by extension. Okay, well, you are probably familiar with these concepts, but just wanted to sort of bring home this message that we can actually summarize and generalize over a large data set using some basic statistical techniques and tools. What is also very important in statistics is that we can find relationship between our data points, right? Imagine, again, going back to the same example of the British National Corpus, and in this case, we are interested not only in adjectives, the use of adjectives, but the use of verbs as well, right? So, again, this is a real example, a random sample of 11 authors from the British National Corpus, fiction writers, and I can sort of list these numbers. The top row is the familiar row with the adjectives. The bottom row is the row with the verbs, right? Okay, what's the relationship when you look at that? Well, a very basic way, a statistical way of capturing this relationship will be to give you something like that, a line, right? And I'll give you a bit more context here. What this line shows you is the relationship. What I did here, and in statistical terminology, this is called a scatter plot, right? A particular type of graph, where I showed the number of adjectives on the x-axis and the number of verbs on the y-axis. Each circle in this graph is an individual author in the British National Corpus. So what I can see here in this very simple graph is the relationship between the use of verbs and the use of adjectives in the data, right? And I can summarize this when I fit the line, what is sometimes called a regression line, or the line of the best fit, right? I fit a line that goes right through the middle of the data cloud, right? So I can summarize the relationship. And what I can say here, based on this, and you can probably see this already, is that there's an inverse proportional relationship. So the more adjectives I have, or the authors use in the text, the fewer verbs, and vice versa. And again, you can think about this, whether this makes sense stylistically. And I think it does. There's a sort of a competition, it seems, between these sort of very descriptive use of language with lots of adjectives, but not so many verbs, and this very dynamic style of writing with lots of verbs, but not so many descriptions. Right? So I think this sort of makes sense also when we look at the data and think about how people experience language as well, which is, I think, very crucial in statistics. We shouldn't stop here. We should always think about what this means in real linguistic terms. Okay, and third thing that we can do with statistics, and that statistics does on a regular basis, is building models. When we talk about models in statistics, we just mean equations, quite sort of complex equation. Regression model is a very, very good example of that. It's a very complex equation where we sort of factor in all sorts of variables, and we'll talk about variables in a moment. I just would like to give you a non-linguistic example that sort of tries to illustrate the same thing. Imagine that we have a task, and we want to find out what the area of Great Britain is, and I mean just the main island, right? Well, how would you go about that? Obviously, you can go and Google that and see what Wikipedia says, right? That would be the easy way. But think about a principled way. How would you arrive at that using some mathematical techniques? Well, you might remember from your school years that there are some equations that we can apply. However, for geometrical shapes. However, of course, there's no equation for the area of Great Britain, right? It is far too complex, far too fuzzy as a geometrical shape. What we, however, can do is we can apply a geometrical model. We can apply a regular shape to the shape of Great Britain, of the main island, to see whether any shape would fit as an approximation, as a model that would summarize the area of Great Britain. And we can try different models. I've already started trying some sort of a rectangular model. Well, you can look at the model and you can see, well, it sort of covers the area, but it covers large areas of the ocean and a bit of island as well. So it might not be such a good model. We can try a circle like that. Again, there are some problems. Some parts of Scotland are not covered here, so and large parts of the sea are covered here. Well, if I fast forward, get something like that, a triangle. Out of the three, you might agree with me, and hopefully you do. The third one fits best, right? So what we are trying to do is we are trying to find a geometrical shape that will cover the area of Great Britain. Of course, this is not a perfect model, and models never are perfect. There are approximations. Okay, so if we settle on the triangle as the best model for the area, then the sort of next step is really to calculate the area of the triangle and try to see whether we can get an approximation of the area of Great Britain based on that. For a triangle, and this is the equation you might remember from the past, from the school days, an area of the triangle is a simple equation. You just take the base and the height over the base. So this is the base, and this is the height over the base. You multiply these numbers and divide it by 2. A very simple equation, right? A simple model here. When I do the mathematics behind this, I get this number. 234,000 square kilometers. Well, now I can go to Wikipedia to see, how well the model represents the reality. I think, that's pretty close, right? And in statistical terms, I have the model and the reality, and the difference between the model and the reality is something called error. In statistics, error is actually not a bad word, right? Error is part of statistical modeling. We have fuzzy reality out there. Linguistic reality, social reality is really fuzzy because we are dealing with real people, real language, right? So we can't capture that by exact mathematical expressions, but we can approximate it. And that's why we always have to think about our statistical analyses as approximations, using models that can be more or less useful for capturing the reality. Right? So this is the sort of third take on statistics. We can generalize, we can find relationships, and we can sort of model the complex linguistic and social reality that is out there. Okay, everyone's with me so far? Okay, brilliant. Okay, in very practical terms, okay, what do we do with statistics? Because I think statistics is a toolbox, right? We have different tools, and it's a means to an end. We want to find out something interesting about language and society, but we have some tools that can be useful and that can be usefully applied. There are two large areas of statistics, descriptive and inferential statistics. And we can therefore describe and infer things. Right? And I'll talk about these more in a moment. Just a few keywords or key concepts that go with these two areas of statistics, and you might be already familiar with many of these. So when I describe, I'm talking about data sets, frequencies, dispersions, distributions, graphs, and in corpus linguistics also collocations. Right? We are describing a relationship in the data. When we use inferential statistics, we are talking about p-values, statistical tests, null hypotheses, confidence intervals, and so on. Right? Don't worry if you don't know these words. That's absolutely fine. This is just a sort of very brief overview of what's out there, right, in statistics. And we'll touch upon the most important concepts in the rest of the lecture. Okay. When we think about statistics, we can also think about different dimensions of statistical analysis. And you can think about these as steps in your analysis. When you gather the data, what is the sort of next step and the next step and so on? How to approach it, right? So this can be sort of a useful guide for you when you go through the process of analysis and try to find out the answer to your research question, regardless of what the research question is, whether it is a sociological research question, linguistic research question, or any research question, historical research question, any research question we might have that involves the use of statistics, and in this particular case also the use of language. Okay. Well, first of all, we always start with some sort of data exploration. And I'll always show the dimension, the key question or questions, and some of the key terms within this dimension. So we start exploring data, and the question that we are asking is, what are the main tendencies in the data? Right? We want to see what's happening there, what's going on in my data. I've just collected the data. I'm very keen to know, right? So I want to look at it. We can visualize the data, use different graphs, and I'll show you some of the options in a moment. We can calculate means, and I already mentioned mean or median as the measure of the central tendency. We also compute standard deviations, and I'll talk about standard deviations in a moment and why they are important. So here's an example of of data exploration. What I have here, and again, the name of this graph is a box plot, right? Because we have some boxes here. Right? What I am showing you here are three corpora. Doesn't matter which corpora these are, right? Three very small corpora, corpus 1, corpus 2, corpus 3, and I'm measuring or looking at the frequencies of a linguistic variable. Again, doesn't matter which linguistic variable this can be any. All right? What I can see here are the individual texts in my corpus. These are the circles, again. And I can see the distribution of the data. The boxes show me the middle 50% of the distribution of the data. Some boxes are smaller, some boxes are larger, depending on how far apart the frequencies are in that particular corpus. So that already gives me some sort of information about that. I have the two major central tendencies in the data indicated by the thick black line, that's the median, the middle value, and the red line is the mean, right? Sometimes they are close to each other, like in the case of corpus 1 and corpus 2. Sometimes they are far apart, right? Well, the reason why they are far apart in corpus 3 is that we have this outlier here, right? So an extreme value that pulls the mean towards it, right? So again, you know, useful exploration of what is going on here. The outlier is actually very interesting because we can think about, okay, well, is it a genuine value or is it some kind of measurement error? Have I mistyped something when I was doing the analysis? And then, you know, there are different implications of the answer to this question. So again, I can see everything that's in my data here, all individual texts, and also how they relate to each other in a sort of formal way. Again, don't worry if you don't understand all the details of this graph. This is just an example of how data can be visually explored. Right? If you haven't seen a box plot before, it might take a while to get familiar with all the features of a box plot. We can, you know, look at a distribution from a different angle. This is a distribution of a single linguistic variable. Think about the passive voice or something like that in a corpus. And I'm using a histogram, a sort of a bar plot that shows the distribution and whether the distribution is sort of a normal distribution or sort of slightly skewed. This is a slightly positively skewed distribution. And again, that has some implications for the statistical test that I can use later on. So again, doesn't matter, you know, whether you understand the details of this. This is just an illustration of what I can be doing at this stage. Looking at the data from different angles, using different visual techniques or different descriptive statistical techniques to just see what's going on there in the data set. Again, I've shown you a scattered plot previously with the verbs and adjectives in British national corpus. Here, again, doesn't matter. I'm showing a relationship between two different variables. The same idea. I can even plot data on the map, right? When I have corpus data, and again, this is a real example. What I did here was I searched the British national corpus and I searched the places, the place names where British people go or travel to, right? And this is a top 10. Well, London is number 1, no surprise. Do we have anyone from London here? And of course, you know, there are places across the UK, but the places that are outside of the UK are New York, Paris, and Rome, as you can see from the map. The size of the dot on the map actually reflects the frequency with which the place name appears in the context to go or travel to in the British national corpus. So this is real data reflects the preferences of the British authors and speakers in the early 90s. Maybe this has changed. We are building a new British national corpus here, so we'll see whether there are some shifts to this as well. So the point of this one is that you can get quite creative, right, in the way you explore the data. And you can link data with different types of visualization, with maps and so on. And you can do that with computational techniques very, very easily. I produced this one very quickly just last night. Mean, we already talked about that. The formal equation is this: sum of all values divided by the number of cases. Again, something very familiar. We are just formalizing this here, right? This would be sort of a commonsensical equation. Okay. The second area or step in our analysis, when you think about it as a process, is inferential statistics, right? When we talk about inferential statistics, we are talking about whether something is statistically significant or not. We are talking about p-values and confidence intervals. All these belong to the area of inferential statistics. And inferential statistics is very often misunderstood. But all there is about inferential statistics is that we are trying to evaluate whether we have enough evidence in the data to reject the null hypothesis. And I'll talk about that in a moment. But the idea behind inferential statistics is very simple. Imagine that I'm interested in the use of the word love in a British corpus, in a large British corpus, right? Well, first of all, I can start with the first example, and this is a really, again, I like this example. It is a real example from the BE06 corpus, 1 million word corpus of written British English. Love is all around us. Well, if I have just this one example, how much can I say about the use of the word love? Well, not much, I would argue. Well, we know that love can be a noun or a verb in English. I have only the nominal use here, the use as a noun here. So again, and I can't see the other context in which the word love appears. So when I have one or very few examples, I have only limited evidence about what I can say about the particular use of the word, or all the uses of the word. So what I need to do is go along this line, along this scale, and collect more and more examples. And large language corpora allow me to do this very quickly. You just type in the word and get all the examples, right? In corpus linguistics, this is the idea. So what I'm really looking for is a large enough sample, something like that, in corpus linguistic terms. Right? Again, these are all the examples of love from the BE06 corpus that allow me to take this step of inferential statistics and infer something about the population, right? So again, regardless of the particular research question, but in general, what I'm interested in is not really what is in the corpus, but what is in language as such. You know, all uses of language in the population, right? How people use language in general, what British English is about, how British English uses the word love in this particular example. So I'm collecting a sample, and I'll talk about the statistical terminology in a moment, to say something about the population. Right? So I'm not interested in the corpus per se, but I'm interested in a larger picture, right? How people use language. So this is what inferential statistics can help me with. Right? It is about the amount of evidence. That's the summary. One sentence summary of inferential statistics. The third area, last but one, is the area of effect sizes. And you've probably heard effect sizes. If you know something about statistics, you've probably heard effect sizes being mentioned, and probably more and more frequently in recent years in all sorts of disciplines. Effect sizes are fairly straightforward, simple measures, sometimes standardized, sometimes non-standardized, of just the amount of effect that we have in the data. The key terms are, of course, effect size, and some specific examples are Cohen's d, the R coefficient. If you know correlation, you probably know that we produce something like a correlation coefficient R that shows the relationship between two variables. Well, that's an example of an effect size. Right? What is important to remember is that statistical inference and effect sizes are two, well, related, but conceptually very different areas of statistical thinking. And nowadays, there's a shift of focus more towards effect sizes, because the great thing about effect sizes is that you can compare them across different studies, put them together and combine them in meta-analyses, right? And in fields such as applied linguistics and psychology and other disciplines, we carry out meta-analyses where we put the studies together. The thing with p-values and inferential statistics is that you can't compare them directly. Right? So that's why we are interested just in the real practical effect of what is happening there. And you can imagine this as, you know, as a sort of a formalized way of saying, is there something observable, something, you know, that we would see in the data as stylistic effect when we read the text, right? You know, imagine the, you know, adjectives in fiction writers. Would a reader be able to spot this as a difference in style, for instance? And we want to quantify this in some statistical terms. So this is what we do in effect sizes. Again, don't worry about the details. It is important to know, A, that effect sizes are important, and B, that these are sort of two different levels of statistical thinking when compared to statistical inference. And finally, okay, this is the measure of an effect size, just an illustration. Linguistic interpretation. And I think we don't stress this often enough, but I think what we really need to do is think about the real term implications, the linguistic interpretation of what we see in the data. Statistics is not about number crunching, or shouldn't be about number crunching. This is just a means towards an end, right? I think, we are linguists, social scientists, historians here, or, people from, all different backgrounds. And we have our disciplinary knowledge of the literature, knowledge of the field. And I think we should bring this to our analysis, and we need to bring this into the analysis to really understand what's going on here. Just a quick illustration of this. This is Lancaster Market. That takes place every Wednesday and every Saturday. And there's a whole mix of people buying, selling things. This is a very famous bookstore there. You can buy books and CDs or whatnot. And people just communicate. And I think we have to have this type of picture. I take the Lancaster Market as a metaphor of the society and all the sort of various social interactions that we have to really relate all the numbers to. Right? Our analyses are not about numbers. The numbers are just the middleman in here. Right? We want to know what's happening in the society. And I think this is very important to bear in mind, because not all statistical approaches do this. Right? The sort of final step, which I think is really, really exciting. Okay. I said that a good starting point, and now we are sort of trying to move to the area where statistics can help us with the data, and then later on with analysis with some very specific techniques. So the first step is really to think about the research design, right? When we have a study, we want to investigate something, we have a hypothesis, or we have a hunch or something, we want to investigate something, and we want to collect data. So I want to talk about corpora as data sets and how corpora are important, and also the fact that we have to be really critical about the choice of corpora or the compilation of corpora, because that has implications for our future studies. If you are wondering about the acronym before the word warning, this stands for garbage in, garbage out, right? When you input something that is not quite quality data, no matter how sophisticated your statistical procedures are, you just get garbage out, right? And that's quite commonsensical. But we rarely, I'm afraid to say, pay attention to the quality of the corpus data and what went in. Now, corpus is a sample in statistical terms. Some corpora, in very few cases, collect all the population, if they are very specialized. I don't know, all speeches by Margaret Thatcher. Well, we can probably do all public speeches by Margaret Thatcher. We can probably collect that as a corpus, and we will have the whole population, right? But in most cases, corpus is a sample, and no matter how large the corpus is, it is always a very small sample compared to the population, which is all uses of language out there. When corpora started in the 1960s, 70s, the largest corpora, the biggest achievements, were something like 1 million words collected for the British English and the American English, the early corpora, Brown and Lobb, Lancaster, Oslo, Bergen corpus, one of the early corpora created here at Lancaster in collaboration with other universities. When we moved to the early 1990s, and this is the size of the British national corpus, right? 100 million words was the sort of the top end of sort of corpus compilation. Throughout the 90s, we got to something like 500 million words. This is the size of the Bank of English, or the COCA corpus, the corpus of contemporary American English, compiled by Mark Davies and a source of American English information. Well, currently, when we look at the largest corpora available, they won't even fit the screen. And you need to take a step back to see how large they are in comparison with the early corpora. Right? One of the largest corpora I've ever used was a 20 billion corpus of the English language based on web crawling, or the web resources that are available that were processed linguistically. However, the message of this is that corpus is always a sample, no matter how large. And I would like to show you some examples. Here's a table that gives us frequencies of 1, 2, 3, 4, 5 words or expressions. Words or expressions that we probably understand when we read them: co-pilot, rater, beautiful memories, somewhat humorously, and a tongue twister, uninhabitably, as an adverb. Right? What I have here are the frequencies of a 1 million in a 1 million corpus of current British English, 100 million corpus of British English, and 20 billion corpus of British English, just to see, what the frequencies are. Well, obviously, if you look in the 1 million word corpus of British English, you won't find any examples of these expressions, although we probably understand what a co-pilot is, right? The first officer on a plane. And the other examples are also fairly self-explanatory. In British National Corpus, we have a few instances of the first 3, but no instances of the last 2. Although somewhat humorously, sounds like a good British expression, right? Or we might find context, or might be able to think about context in which we might like to use that word. Right? Well, yeah, we have some evidence in 20 billion words, and 20 billion words is really a lot. But not that many when we look at the last 2 expressions. And just the take-home message of this table is that words are rare. Words are really genuinely rare, and combinations of words, combinations of 2 words or 3 words or 4 words, are even rarer. So we have to be really careful about how we interpret the zeros here. Right? Doesn't mean that the word doesn't exist. It doesn't mean that the word is not used. Right? The zero is really ambiguous in many respects. Right? And so a good rule in statistics is that absence of evidence is not an evidence of absence. Right? When we have the zero, it doesn't mean that we don't use that word. Right? The words are rare. That's the take-home message from this one. Okay. Corpus is a sample, but what do we mean by that? Well, the corpus, and in this metaphor, is the container in the middle here, and the color around it is the population. All sorts of uses of language, different genres, registers, spoken, written, newspapers, academic writing, fiction, and all sorts of uses of language out there. What we do, or what we should do when we think about sampling, is the sample should go, like this one, through all sorts of uses of the language, and just sort of capture the basic features of that. When we do this properly, and in statistics, we are talking about an ideal of a random sample, truly random sample, right? The truly random sample, in an ideal case, would perfectly represent the population. So whatever we say about the sample would be true about the population, because, well, the colors match here, right, in the metaphor. Well, this is rarely the case, right? Because our sample is rarely truly random. It's more opportunistic. The data that we can get hold of, right? The texts that are out there, some are copyrighted, so maybe we can't use those. Some are not. A lot of the conversations that we are part of are never recorded. right? Think about, the dinner table conversations you have with your friends. Well, these are, just happen in that moment, and there's never a record of that. So they can't be part of the corpus, right? So a corpus is something slightly different from this ideal. The problem is, though, that statistical techniques assume this ideal. Right? We assume that if the data are randomly sampled, then the sample can tell us something important about the population. What we can do as linguists, sociologists, historians, analysts of language and society is to look at the sample, look at the corpus, look at the data we have, and ask two important questions. How representative is this corpus? How well it reflects the population, and what are the limitations of this representativeness? And is it biased in some way? Do we overrepresent something, a part, academic writing, because it's easy to download it from the internet, and there are many journals out there, something like that, or web registers, is it easy just to grab the online material that's out there because it is easy to obtain. But there are implications for what the corpus can and does represent. In very practical terms, just to give you some insight into what we do as corpus linguists when we build corpora, and we build a lot of corpora here at Lancaster, we usually start with something that is called a sampling frame, right? A set of categories that we want to cover in the corpus, so that we don't forget about something, and that we have the main genres or registers or uses of language covered. This is one of the most famous sampling frames that dates back to the 60s, and that's the Brown family sampling frame. And there are many, many corpora that are sampled according to these traditional written genres. So we are looking at a general written corpus. Right? And again, we are starting with newspapers, then we have some general fiction, or general prose, fiction, and different types of language. So we sample across these 15 different subgenres or sub-registers. In very practical terms, what we do is we decide on the number of texts that we want to include in each category, and then we just go out and obtain that number. We sort of try to make sure that these texts do not come from the same source, that is equally distributed among the sources available. And also in this particular case, because we are taking smaller samples, we are not taking the whole text in the Brown family, we need to make sure that, for instance, there's an equal distribution of the beginnings of text, middles of text, and ends of the text, because, again, that has some implication for what we can get when we search the corpus. Right? So all these details need to be taken care of, and all these details we need to look at critically when we use the corpus. And I think, most of you, if you have some experience with language corpora, you might have experience with the corpora that are already out there as users, as corpus users rather than corpus compilers, although you are able to, or you will be able to, after the summer school, you will be able to compile your own corpora. So no matter in which position you are, you always have to be critical, because it is very easy to delegate the responsibility to the corpus compilers. I very often hear, well, I found it in the British National Corpus, so it must be true. Well, really? And what do you mean? Have you ever thought about what the composition of the corpus is? It is a corpus compiled in the early 1990s. Well, is it still general British English, both spoken and written, and what are the proportions of speech and writing, and all sorts of these nagging questions that we need to ask. We are compiling now a new British National Corpus here at Lancaster, so there at least will be a point of comparison with the old BNC, which is now 20 years old. So again, just a word of caution. We need to think critically about our data as the starting point. Why do we care? Well, in corpus linguistics and in quantitative analyses, we are interested in frequencies of linguistic variables, features such as words, phrases, or grammatical structures. And I think Jeff Leach really nicely summarizes that. He says, if asked what the one benefit that corpora can provide and that cannot be provided by other means, I would reply information about frequency. Right? I think this is the whole value about corpora. But of course, frequency and distribution and uses in context and all that. Right? But we can quantify all these things. So I think that there's some very elementary truth behind this. Okay, frequency. So when we are looking at frequencies and dealing with frequencies, we also need to know where to count. And that's where different types of research design come into play. I think generally when we look at corpus linguistics, there are three answers to the question of where to count the data, right, depending on what we do. Until recently, the most prominent one was what I call the whole corpus design. We would search a word or phrase of interest in a corpus, and we would get a frequency per corpus, right? That's a whole corpus design. However, more and more people nowadays started looking inside the corpora and the distribution of the word or phrase inside different parts of the corpus, genres, registers, but also inside individual texts, right? So the second approach is to look inside the corpus and trace the frequencies, count inside the individual files or speakers. And the third approach is to focus on a linguistic variable, and this is especially important if we are interested in grammatical variation and sociolinguistic variation, this sort of traditional variationist paradigm. Leboff and other people who introduced this paradigm into linguistics. And there we are focusing on all the instances of a variable, where a variable and its different variants can occur. I'll give you a particular example in a moment. So here are the three research designs. As I mentioned before, the whole corpus design, and again, this is a real data set, I'm interested in the frequencies of the passives, right, the passive voice. This was done by someone, right? So that's an example of a passive construction. And in the whole corpus design, what I would do is I would take the British National Corpus, count the number of passives, right? Quite a few of them, right? Over 1.1 million, if I count correctly. This is the relative frequency per million words, right? And this is what I would report in my research report, right, in my study. Well, very important, but I think we can go beyond that. If we are interested in the same linguistic feature, the passives again, but we follow the individual text or speaker design. In this case, and I'm showing you only the first 10 data points in my data set, there are 4,000 more down here that I'm not showing you because there are 4,000 different texts in the British National Corpus. These are the individual texts, and these are the frequencies, and I can sort of normalize that per text length. We'll talk about that in a moment. Right? So this gives me more information about the distribution, right? How the linguistic variable of interest is distributed in the individual texts. Right? So I can see the outliers, I can see all the nice features, who's using them a lot, which genre, which register uses those a lot. Does academic writing use them more in comparison to fiction or something like that? The answer is yes, but we can provide evidence for that. And this is the sort of grammatical type of analysis in the tradition of variationist linguistics, where we search for all the examples of the passive. And this particular data set, again, there are hundreds and hundreds of examples down here, so this is a very long data set, right? Here we have the examples of the passives are usually cut, have been deployed, or has been deployed, are meant, was caused, are scheduled, and so on, all the passives in the British national corpus. And in this particular research question, I'm interested in the variation between the long and short passives. The passives with a by phrase, this was done by me, or just this has been done, full stop. Right? So I code this in the data set, short and long. It doesn't matter. You know, I'm using short as 0, long as 1. Right? It doesn't matter what label you use here. I code whether this is speech and writing. I code which genre this comes from, and so on. Right? And I can sort of input this into the statistical model and see what the interaction between the variables, between the external features, and the use of the passives is in English. So this is a data design that suits this type of research question, sort of more focused, linguistic-y research question. Okay, so that was the answer to the question of where to count, right? Another question that we might like to ask is what to count. And here we are talking about variables. And I already mentioned the term variable, so let's just formalize it very briefly. In corpus linguistics, we usually are talking about two types of variables. Linguistic variables, this is the variables that we are interested in, linguistic features, words, frequencies of words or phrases, and explanatory variables. The variables, the contextual variables that help us explain what is going on. These can be the register, genre, type of speaker, speaker's gender, age, and so on, you know, whatever we are interested in. Well, I won't give you a formal definition here. Here's one, but I think what is important to know about variables is that variable is something that can vary, right? Take on different values, as we call them, right? Variable is something that captures different variants, different values that it can take. A very practical example, again, from a real research study that we've done with a learner corpus, this time spoken learner corpus, Trinity Lancaster spoken learner corpus. What we have here are data from speakers using English as their additional language, right, from different parts of the world. The code doesn't matter. I just know that this is a Spanish speaker. This is a speaker from Sri Lanka, speaker from Mexico, Italy, China, and so on. We have their gender, their proficiency, whether they are beginners, intermediate, or advanced. And then I'm interested in what the linguistic variables are, the use of the first person pronoun, second person pronoun, and all pronouns together, right? Just as an example. In statistical terminology, the linguistic variables are here. These are the explanatory variables, the variables that help me explain what is going on in terms of the linguistic variables. And there is a sort of sub-terminology that I can apply here. The gender is something that is called a nominal variable, right? And this is about the behavior of the variable, what the variable is about. I'll explain that straight away. Nominal variables are labels without any particular order, right? Male, female, right, is a label. There's no particular hierarchy there, right? Well, conventionally, I just used 0 for male and 1 for female, but that could be the other way around. There's no order between these variables. These are just labels. Proficiency, on the other hand, is something that is called an ordinal variable. There is order, right? I can sort the speakers according to their proficiency from beginners through intermediate to advanced, right? And again, there are some implications for the sort of types of tests and types of analyses that I can carry out with these different types of variables. And finally, we have something called scale variables, variables that operate on a scale, right? And they usually have we usually have these sort of numbers with decimal points because we are measuring it precisely on a scale. And these are the relative frequencies of the linguistic variables in the individual speakers. Right? So we have these three types of variables that behave differently for statistical purposes. Again, for you to know, what was important to know is that we have to pay attention to the type of variable that we are dealing with. Okay, descriptive statistics. We are comparing frequencies, but what sort of frequencies are we talking about? In corpus linguistics, we have two types of frequencies. You are probably familiar with that already: absolute frequencies and relative frequencies. When I show you a word list, this is, again, a word list based on the British National Corpus, the most frequent 10 words in the English language. I'm listing the absolute frequencies and the relative frequencies per million. And this is the usual way to present frequency data in corpus linguistics. We present the absolute and the relative frequencies together. The absolute frequencies are just the number of hits, number of occurrences of the word or phrase in a corpus, whereas the relative frequencies, and I'll show you an equation in a moment, is a frequency normalized to a certain basis of normalization, and I'll show you what I mean by that. The relative frequencies are very useful if we want to compare frequencies across different corpora or subcorpora, genres, subgenres within the same corpus, because there are different parts of the corpus of different sizes. So this is very, very important. The relative frequency is calculated as the absolute frequency divided by the number of tokens in the corpus times certain basis for normalization, and we'll choose this basis for normalization. If we have a very large corpus, it can be 1 million per 1 million. If we have a smaller corpus, it can be per 10,000 or per 1,000. We want to reflect the actual size of the corpus when we choose the basis for normalization. Here's the example: the relative frequency of the preposition of in the British National Corpus. Here are the numbers. You can read them. The British National Corpus, the total size is roughly 100 million. This is the exact size. The number of hits per preposition of times 1 million. So 30,946. This is the number that we got from the corpus tool. Right? So this is how we arrived at this number. Right? Relative frequencies are very basic but very important concept in corpus linguistics. When we report frequencies in corpus linguistics, we also need to report distributions. Right? We are not only interested in how many times a word or phrase appears in the corpus, but we also want to see whether the word or phrase is equally distributed in the corpus, or whether there are sort of some places, types of genres, types of text that the word or phrase appears more frequently in. And that's where the term dispersion comes in. Right? Imagine that we have a corpus, and the corpus has 6 different sections, and imagine these sections being different genres or registers: newspapers, academic writing, and so on. We have a word of interest that appears 10 times in the first section, twice in the second section, once in the third section. It doesn't appear at all in the fourth section, 12 times. This is the most popular use of the word in this section, and then 5 times in the last one. Right? And this is the distribution. So how would we quantify this again? How would we generalize over this? This is the same type of exercise as we talked about at the beginning. Well, we can graph it to see, okay, the distribution is unequal. And we have different measures of distribution: range, standard deviation, Gillian's D, and on the next slide we have another one that is called DP. Range is the simplest one. Range basically tells us the number of sections that include the word. In our case, we just make a decision: is it there or isn't it there? And say range is 5, right? 5 out of 6, right? A very simple measure of when we divide the corpus into these sections, in how many of them we can see the word or phrase. Something you might be familiar with is a dispersion measure called standard deviation. And this is a very universal measure of distribution, not only in corpus linguistics, but in social science, natural science, basically anywhere. The standard deviation is calculated, and this is an equation that might, at the first sight, look fairly complicated. It is a square root of the sum of squared distances from the mean divided by the total number of corpus sections in this case, right? The total number of texts or sections. The idea behind this is, however, very, very simple. And this graph should help you understand that. Again, we have our 6 sections here. The frequencies are plotted on the y-axis. So these are the data points that we have. The squares are the data points that we have in the corpus. The line, the orange line, is the mean, the central tendency. And the arrows and the numbers next to the arrows show the distances from the mean, right? How far the individual data, the individual sections in this case, are from the mean, right? And this is what I want to capture in standard deviation. Well, one of the options would be just to add all these distances together. But what happens if I add all these numbers together? So 5, minus 3, minus 4, minus 5, and 7, and 0. I get a 0, right? They cancel each other out, and very often they do so, right? So in order to compute the overall distance of the individual data points from the mean, I calculate the squared distances. This is to get rid of the zeros, right? This is just a mathematical trick to get rid of the, get rid of the negative numbers, right? And then I can add them. And again, because I square them first, I take the square root. This is just to get back to the original scale. And I have the mean here. When I compute it, I get something like 4.55. I always have to relay the standard deviation to the mean and report it together. So the size of the standard deviation has to be interpreted in relation to the mean. In this particular case, it is almost as large as the mean, which tells me that there's a lot of variation. Right? The mean sits somewhere in the middle, but there's a lot of variation around it. Julian's D just plugs in the standard deviation and uses a standardized scale from 0 to 1 to express the variation. Right? So you can, whereas standard deviation cannot be compared across different words and phrases because they have different means and different frequencies, Julian's D allows us to compare these across different linguistic features. Again, don't worry about the equation. It's the standard deviation over mean divided by the square root of the number of corpus sections by -1. The idea is to look at the observed variation and divided it by the maximum possible variation in the data given the number of corpus sections. Again, some mathematical wizardry around this. What you need to know is that on a scale from 0 to 1, this sort of operates on a scale from 0 to 1. 0 is extremely uneven distribution, and 1 is a perfectly even distribution. When we run the numbers for our particular case, we get something like 0.59, which sits somewhere in the middle, but closer to the perfectly even distribution. Right? Not quite there yet. Right? So there's a lot of variation. It's closer to the even distribution than to the extremely uneven distribution, but you know, somewhere there in the middle. Finally, the last measure of dispersion is called deviation of proportions. This measure is especially useful if we have multiple, very large number of proportions, because all the corpus sections or texts where we trace the dispersion, because Julian's D tends to be skewed if we have a very large number corpus sections skewed towards even distribution. DP compensates for this. If we have a limited number of sections, they don't output such a different number. They operate on a slightly different scale, though. Again, an example here. What we are trying to do is we are looking at the sizes of the sections, and let's imagine that the sections are of equal sizes, 100,000 words each, right? Just for the simplicity's sake. They rarely are in real life. We have the distributions of the words here. What we calculate are expected proportions, and we can express them as decimal numbers or percentages. What we are saying here is that based on the sizes of the sections, we would expect about 17% of the cases of the linguistic variable in each of the sections, just equally distributed. Should they be equally distributed, and this is the expected frequency, what we would just expect if the data were equally distributed, we would get 17% in each, right? This is basically when we take 100,000 and divided it by the total number of corpus items, which is 600,000, right? So that's 17%. However, when we look at the proportions of the distribution, we get 30% here, 7% here, 3% here, 0% here, 40% here, and only in the last one, the observed matches they expected, so 17% here. Right? So what we do when we compute the DP is we just take the observed minus expected proportions. We add these numbers together and divide it by 2. When we run the numbers, again, we get something like 0.385, right, for our particular example. Again, it sits somewhere in the middle on the scale from 0 to 1, but note that the poles here on the scale are reversed. This time, 0 means perfectly even distribution, so the ideal case, right? And 1 means perfectly uneven distribution. So what this tells us is that this is basically a mirror image to the Jullien's D, right? Jullien's D with something like 0.6, this is 0.4, but these are the sort of same interpretation. It's closer to the perfectly even distribution, but not quite there yet. Right? And we can compare different numbers for different linguistic variables. Again, the advantage of DP is that it operates on a standardized scale, so we can actually measure different linguistic variables using this statistical measure. Overall, as a sort of take-home message from the dispersion measures is that we shouldn't be really satisfied when we do our corpus research with quoting just one number when we look at corpus frequencies. Well, when I search for a word or phrase, I can say something like, it appears 30 times there. But that would hide all the distributions of words in the individual sections or in the individual texts. And they might be, quite diverse, as in this example. So what I need to do is quote both the frequency in the corpus, the central tendency, but also, and that's very important, and it is not done as often as it should be, the dispersion, the measure of deviation from the mean, right? And I can express it in different terms: standard deviation, range, Jullien's D, or DP. What I would like to do now is to move on to the null hypothesis significance testing paradigm. And I would like to talk about hypotheses in science and hypotheses in statistics. And I think, many of you here, if you are working within the quantitative paradigm, might be testing different hypotheses, right? Hypothesis is a scientific statement that we want to test. Right? We read around, we read the literature, explore the data, come up with some hypotheses, and then we apply the technique I'm going to talk about to test this hypothesis. Right? To give you a specific example, a sociolinguistic hypothesis can be that men and women use language differently, and I would have to operationalize it in some particular way. So, I could be looking at swear words, so I can say men use more swear words than women. Within this statistical paradigm that is called the null hypothesis significance testing paradigm, what I have to do as the second step is formulate something that is called a null hypothesis. That is sort of a reverse hypothesis that I'm interested in. Basically, the null hypothesis claims that there is no effect in the data. In this particular case, that there is no difference between male and female speakers and in how they use language, swear words in our example. So this is done for operational reasons, and this is done on a regular basis, because in the logic of the statistical testing, we can actually apply the procedure to null hypothesis and then make some inferences about the hypothesis that we are really interested in. That's our original hypothesis. That's on the top line here on the slide. Okay, I go out, collect the data, or use a corpus that is available, have two subcorpora, male corpus and female corpus, and get two numbers, 16 and 14. Is there a difference? Not so much. Well, 16 is not 14, so there, at some very trivial level, there's a difference. But the question is whether this difference is statistically significant. Because what we are dealing with are samples. And obviously, the samples reflect the population. Well, in theory, they should. But there's also something that is called sampling variation. When we take a sample of male speakers, and when we repeat this process, the sample, although we apply all the rigorous procedures, will always differ slightly, right, by chance alone. Right? We happen to sample a particular type of male speakers or something like that. Even if we do the truly random sampling, this is the case. So we want to know whether this difference is likely to be a real difference in the population, in how male and female speakers use language, or whether this is just an artifact of our sampling. Right? And this is the question that we are trying to answer in this procedure. So, is the difference due to chance, or is it statistically significant? In other words, if we rephrase the question, how much evidence in the two corpora do we have to reject the null hypothesis that says that there is no difference? Right, so do we have any evidence? Do the corpora, the 14 and 16 frequencies, show us some evidence that there's a difference, there's a real difference in the population? In very practical terms, what we do is we formulated the null hypothesis that says there's no difference. We run a statistical test, and that applies to all sorts of statistical tests, right? Within this paradigm, it can be a t-test, ANOVA, Mann-Whitney U-test, chi-square test, regression, and all sorts of tests that produce a p-value. Then we get the p-value, the probability value. P stands for probability. And then we need to interpret the p-value, the probability value. First of all, let me pause a while and just sort of talk about p-value. You've probably seen p-values if you've read quantitative studies, or if you carried out your own quantitative studies, you've used p-values. But what's the interpretation? Well, p-value is the probability of seeing the values at least as extreme as observed if the null hypothesis were true. Well, this is quite a complex notion, so let me unpack that. Right? We are looking at the data, the evidence that we have in the data, and we are trying to assess the probability, and we are hoping that the probability is very, very small, right? So our hope is that the probability of seeing the two values, 14 and 16, or something even more extreme, 13 and 17, right, and even more extreme values, under the null hypothesis. So if there is no real difference. Right? it might take a while to process this. Right? In very practical terms, what we get is a number. And either the number is smaller than 0.05, a conventional cutoff point in social science, but we have to decide on that. But in social science, this is a conventional. There's nothing magic about this cutoff point. It's just that we all in the scientific community agreed that 0.05 or 5% is a probability of the p-value that we are happy with. So if we get a small p-value, smaller than the 5%, we can reject the null hypothesis that says that there's no difference in the data. Well, people at this stage usually celebrate and publish articles and are very happy, right? If, however, the probability value that the statistical test outputs is larger than 0.05, what we can conclude is not that the null hypothesis is true. We can never conclude that. What we can conclude is that we don't have enough data to reject the null hypothesis, right? Because maybe if we collect a larger corpus, there will be more data and enough data to reject the hypothesis and move on to the significance level. So we might need to go out there and collect more data to see whether there's a real difference. But currently, we don't have enough evidence to reject the null hypothesis, right? So it is still an open hypothesis for all intents and purposes, right? So this is important to understand. And this actually applies to any statistical test. So this is a general paradigm that applies to any statistical test. Well, the uses, as I said, in corpus linguistics, when we look at register variation, run correlation, the correlation coefficient is usually accompanied by the p-value, factor analysis, when you compare learner language and native speaker language using regression models, mixed effect models. That's all part of this paradigm. Sociolinguistic studies tests such as Mann-Whitney U test, ANOVA t-test, and many other tests that you guys mentioned at the beginning. So this is all part of the paradigm. Before we leave this paradigm, I would just like to mention one point. In current statistical thinking, there is this huge trend that tries to move away the thinking from the null hypothesis paradigm to something that would be more complex estimation of effects, right? The great thing about null hypothesis is that it is quite clear-cut. It is significant or not, right? P-value is smaller than 0.05 or larger than 0.05, and then you can make your conclusions based on that. However, sometimes it might be unhelpful to think about the reality to be split into significant and non-significant. The other problem is that we can't compare the p-values directly across different studies because the p-values really try to estimate the size of the sample. They are about the evidence that there is in our corpora, right? So they really directly depend on the size of the sample, size of the corpus. So you can have a tiny effect in a very large corpus and it will be statistically significant, right? So something that is almost meaningless in linguistic terms can still be statistically significant. So I think these are all the problems that people recognize within this statistical paradigm. So again, the shift of emphasis is more towards reporting effect sizes and confidence intervals around effect sizes. But don't worry about that. This is sort of advanced statistics, so don't worry about that if this doesn't make sense. This is just a sort of general remark to say that there are some limitations to this statistical paradigm. Okay. Final 10 points from statistical thinking as a way of summarizing what we've talked about so far. So, well, I came up with these 10 principles and I labeled them A to J, hoping that they are sort of easily to be remembered, but well, we'll see how that goes. A, attention to detail. Well, when we think about statistics, we think about complex statistical models and equations and all that. But when you think about the real process of data analysis, it really starts with getting the data in a particular shape, manipulate the data in some way, copy-paste the data from one Excel spreadsheet to another. And this can be a source of many, many problems. And again, think about the sort of garbage in, garbage out principle, right? If we don't get these low-level processes right, no matter what we do later on in the pipeline, we won't get meaningful results, right? Things really, such as typing in, imagine yourself sitting late at night trying to finish your research, just the final Excel spreadsheet that you need to finish, and you feel quite tired, and you know, maybe there's something else on your mind, and you just mistype a number. Well, what are the implications of that, right, for the statistical analysis? So my suggestion would be twofold. One is, well, identify the places where this might happen and double and triple check that all the data is correct and as it should be. The other thing is that when we look at the new generation of corpus tools, and you've probably already talked about Langsbox, the tool that we are developing here at Lancaster University, they are trying to integrate the statistical procedures inside the tool. So you don't have to go outside of the tool and do this copy-pasting, or that is error-prone. So you might get all the statistics or the important statistics from inside the tool, and the tool guarantees that this is done in a rigorous way. So that's one of the options. But wherever there's a possibility of an error, I would always triple check that this didn't happen. B, basics first. Well, you know, we might like to already know the p-value, so we might be eager to know whether our results are statistically significant. But unless we understand what our data is about, unless we go through the process of the descriptive statistics, looking at the basic patterns or visualizing the data if that's helpful, we actually cannot interpret the results properly, right? So that's why basics first. Start with getting to know the data, get to know the corpus, get to know the results, the patterns that you observe. Just spend the time with the data, right? And try to see what's happening there. Well, clarity as a principle is always very important. When we apply clarity to statistical procedures, we have to be clear and transparent about what statistical tests we choose and why. The choice of statistical techniques should be clearly motivated. And statistics is really about choices, right? There's no one particular technique that would fit all the data shapes. So we really have to think carefully about what is the appropriate statistical technique for this type of research design, for this type of data. Right? And again, we might find some guidance in the discipline, or there might be some helpful books that can guide us there, depending on how advanced we are in our own statistical thinking. Well, data first. I think, two things to say about data. We have to be critical about the data first. We need to really not to delegate the responsibility, our responsibility as researchers, to the creators of the corpus, right? It is in the BNC. Well, so what? Right? We have to always go beyond this. But also, when we think about the data and we are happy with the data, that the data really is able to answer our research question reliably, then we also have to trust the data, right? Because no matter what our personal convictions are, and we might have strong feelings about how language should be used, or what people should be doing, and these sorts of things. But no matter what our sort of personal preferences are, we just have to be truthful, and we have to look at the data, say, okay, well, the data contradicts my initial hypothesis, but that's great, right? That's something new. That's the innovation in the field. The fifth one is effect sizes. This is just a reminder for us that effect sizes are important, and it is important to calculate them, report them and interpret them when we do our statistical analysis. It is always good practice to report the p-values, and in addition to that, report the effect sizes as well, and perhaps the confidence intervals for the effect sizes as well, so we can interpret them within the population. Okay, following the best practices in the field. Again, it really depends where you are within your discipline, and there are probably many useful pointers and suggestions within your own discipline. It is good, if you are in corpus linguistics, there are some top journals in corpus linguistics that you can search, and you can find articles that deal with a similar topic to yours, and see what sort of procedures the authors used. Right? So if you are a beginner, it is a good starting point to look at the field and see what other people are doing. But I wouldn't stop here, right? As you become more proficient in statistics, and when you think about statistical procedures more critically, it is good to go beyond this. I would like to give you one example. In corpus linguistics, until recently, the use of tests such as the chi-square test or the log likelihood test was something that was the sort of state of the art, when you were comparing 2 or 3 or multiple corpora. However, now we have more and more compelling evidence that this is a highly problematic practice, that the results that you get with this overestimate significance. So you basically get significant results, no matter what your variables are, or almost, right? Because there are some basic assumptions being violated. There's nothing wrong with the tests, but there are some basic assumptions of the statistical tests violated when they are used in this particular context. So again, we need to think critically and look forward and try to see how the field we are in can develop. And we can sort of take inspiration from other fields, look at hard science and other disciplines, and the neighboring disciplines. If you are in sociology, you can look at psychology and linguistics and applied linguistics and other disciplines, because there are so many good ideas out there. So we might just find inspiration there. Graphics. Well, I'm a visual person, you've probably noticed. I sometimes think that images are really powerful. Well, these have to be appropriate images, so using graphs and different visual techniques, and we can be quite creative with that, as long as we know what they represent and that they represent the data. So an image, as the saying goes, can sometimes be worth 1,000 words. Highlighting both similarities and differences, again, I think a very important principle, especially within the null hypothesis significance testing paradigm. Our main focus is on finding differences between groups, right? Finding differences in the data between our corpus and the reference corpus, or between males and females, young and old speakers, or whatever our research question is. But I would argue that similarities are equally as important as differences. Similarities are really interesting, although they don't stand out, right? And it is very hard to find or argue for similarities within the null hypothesis testing paradigm anyway, because all we can conclude is that we don't have enough evidence to reject the null hypothesis, right? But when we look at effect sizes, and when we have a more commonsensical approach to the data, and look at what really the data tells us, we can find words that have been around for a while and keep the steady frequencies across the century, right? Paul Baker talks about lock words in this context, words that have this sort of steady frequencies across context. But that's immensely interesting. The fact that a word kept the same frequency across a large period of time is equally as interesting as the words that go up and go down in frequencies, right? These sort of shooting stars of corpus linguistics. So we just have to pay attention to that and be mindful of this fact. Interplay between statistics and linguistics and other disciplines by extension. We shouldn't stop at our our analyses shouldn't stop at statistical explanation. We always should take the extra step and explain what's happening there in the language and in the society. Because actually that's our training, right? As linguists, as historians, social scientists, right? This is what we know, right? This is what we are familiar with. So we should use it, right, in our analyses. And jargon, okay, well, there's some useful terminology, and then, there's the rest. I would argue that for successful application of statistics, you need to have some sort of standardized terminology, but there are very few terms that you really need to know. You don't have to remember the equations, right? The computers will remember them for you. But it is useful to understand the more general principles rather than the individual jargon, and you don't want to get too technical. And I hope that this lecture wasn't too technical. I try to avoid too many equations, and when I used an equation, it didn't use the mathematical symbolism at all, because I think sometimes you can just use plain language to get across the same constructs and concepts. So these are the 10 principles, and just the last point, in a way of summary. What we did here in this lecture is we looked at some of the basic principles of statistics, and I would argue that understanding statistics is essentially about understanding the general principles, and everything else will follow. In corpus linguistics, we sample language and create corpora. We visualize data, and we want to see data in a graphical form and produce meaningful graphs. We compute frequencies, absolute and relative. We look at distributions, and we use different measures of dispersion, and we also use statistical tests. But we also have to be critical and think critically about the data and the linguistic explanation that the data offers. And I think, when I think about and reflect on, what the most important statistical measure is, I would say the most important statistical measure is the common sense. Look at the data and see what it tells you. The good news is that we have some tools and free tools that can be used to do the number crunching for you. Here are some references to Lancaster tools, Lancaster stats tools that can actually produce all the graphs that I've shown you, all the statistics that I've shown you in this lecture can be very easily produced in the Lancaster stats tools. The principle of these tools is that you take your Excel spreadsheet or Calc spreadsheet, whatever you prefer, you copy paste the data, hit the button, and get the answer. Right? So it doesn't require you to type in any equations, worry about that. You just make very simple decisions about the shape of your data. And there's a sociolinguistic website, BNC64, that we are still developing further, but you can already search 64 speakers, 32 male, 32 female speakers, and see the sociolinguistic patterns there if you are interested in that type of language. Again, it produces the statistical tests for you automatically, so you don't have to worry about that. So that's all from me. Thank you.